Our practice test is giving us the parent quadratic function f of x. So this is our parent function, and we want to look at which graph correctly represents g of x is equal to 2 times x squared. So remember, if we have a number being multiplied to x squared, that is going to tell us a vertical stretch or a vertical shrink. So this a value, they call it, when you're multiplying to your parent function x squared, since it's greater than 1, it's going to represent a vertical stretch. So we're looking for a vertical stretch. Right here in part A, this says vertical shrink, this says vertical shrink, so we know our answers can't be here. And B, vertical stretch, and D also say vertical stretch. But in terms of the graph, what we want to understand is that this number greater than 1, vertical stretch, means it's going to make your graph steeper or more narrow. So you can picture taking the graph and then stretching it vertically, okay? So that's going to be our answer B. This graph right here is actually a graph of a vertical shrink. So we wouldn't pick D. Okay, number 2, we have f of x is equal to this, and we're going to find the function g of x if g of x is translated 3 units to the left of f of x. So basically what it is we are going to be taking f of x and we're going to take that function and translate it 3 units to the left. So what we want to remember is whenever we are translating left or right, that's going to affect the inside here of my absolute value. So the 3 on the outside is going to stay. Oh, okay. And then the k value on the outside, the plus 2, is also going to stay as plus 2, so that's looking good here. And then 3 units to the left, actually, when you're moving left and right, is going to change sign. So we're thinking minus 3, but it is actually plus 3. So now inside, we're going to go from minus 5, and we're going to add 3 to that. Right? See how the 3 stayed on the outside, plus 2 over here, and negative 5 plus 3 combines to give you this. So this is what we're looking for, and that would be C. Number 3, here's f of x, and we're going to write an equation for g of x if g of x is a reflection of f of x on the x-axis. So whenever we reflect on the x-axis, what we want to remember is that we're taking the graph and then we're going to, in this case, flip it right side up. Because it's negative, it's going to become positive. So what we can remember then, just as a rule, if you think back to geometry, reflecting on the x-axis in your coordinates in geometry, x stayed the same and it was opposite y. So the same thing is going to happen with the y value and our vertex. So whenever we reflect on the x-axis, it's going to change the sign for the a value out in front, and it's going to change the sign in front of this k value or the y for your vertex. So the inside with x, any number in there, in this case 0, wouldn't change. So instead of being negative, it is now positive when we reflect, so positive on the outside, and then absolute value of x is going to be left alone, and then positive 3 is going to become minus 3, so my answer is C. For number 4, we're looking for the system of inequalities that represents this graph. So what we can look at first is this line. This horizontal line is y is equal to 1, but since it's shaded below and no solid line, it's a dashed line, meaning there's going to be no underline in the inequality. It's less than because my shading is happening below that line. So y is greater than 1 is going to be the first inequality. So we can cross out greater than 1. Okay, then this line here, this dashed line, let's see, this one we're going to see that it has a y-intercept of -1 and a slope of 2/1. So it's going to be 2x minus 1 for the inequality here. But we want to figure out if this is supposed to be greater than or less than. So if you look at your line here, the shading is happening underneath. You can think of it that way as a shortcut. And so it has to be less than because it's underneath. So then we end up with D as our answer. Number 5, which point lies in the solution set for this system? What we're going to do to figure out if the point is in the solution set is we're going to plug it in for x and y, not only in the first inequality, but it also will have to work in the second inequality. So I'm going to write kind of small on here. I'm going to start by plugging in -4, 6 to see if it works. So the first inequality, when I plug it in, it's -8 times -4 plus 2 times 6. And we're going to see, is that greater than -2? So 32 plus 12. I can already see adding that together is going to give me 44, which is definitely not less than -2. So already A isn't going to work. Okay, so now I'm going to plug in 7 and -2. So let me do this right here. To the first equation, or first inequality, will look like this. 7's plugged in for x, and then -2 in for y. This is -56, and then 2 times -2 is -4. This works because -60 is less than -2. So far it works, but it needs to work for both inequalities. So now I'm going to plug it into the second inequality here. 2 times 7 minus 6 times -2. We're going to check to see if that's greater than 4. This is 14. -6 times -2 is positive 12. And we get 26 is greater than 4. And that turns out to work for both of my inequalities. So that's going to be my answer. If I tried to plug in -6, -9, it wouldn't be true for both of these. And same with 2, 5. If I tried to plug that in, it would not be true for both. So again, looking for the solution, plug in the ordered pair, and needs to make sense for both inequalities to be in the solution set. Okay, number 6, we are going to look at the solving and then look for the first incorrect step. So it looks like you guys just, if I were you, I would take the original equation and solve it myself. So that's what I'm going to do. So I got to write kind of small. Equals 7x plus 14. So I'm going to copy it over and then solve on my own to find the mistake. So -9x plus 36. Okay, so let's see if that's what they did first. Yes, -9x plus 36 equals 7x plus 14. So far it's looking good. Then I'm going to subtract 7x to both sides. When I do that, it's going to give me -16x plus 36 is equal to 14. And it looks like they don't get that for step 2. They have this mistake right here. So it looks like they added 7 to the other side, and really they should have subtracted 7. So it's looking like step 2 is where they made their mistake. So our answer is A. And we're going to find the length of the longest side. That's what they're asking us for. If this rectangle has a perimeter of 126 and the length of the sides are as follows. So we want to remember perimeter means the sum of all of the sides, and it's going to equal 126. So in a rectangle, we want to remember that opposite sides are going to be the same length. So if this is -9x minus 4, this is -9x minus 4. And if this is -4x plus 2, this is -4x plus 2. So what I'm going to do is I'm going to set up an equation so that I can solve for x. Once I have x, I'll be able to plug it back in to find the length of the longest side. So what I'm going to do, there's different ways you can set this up. I'm going to take the long way just to see that we understand. we're adding all of this together. So I'm going to have negative 9x minus 4 plus, I guess it's negative 9x minus 4 again, plus negative 4x plus 2 plus negative 4x plus 2 again. The only reason why I'm using parentheses is because of all the negatives. I don't want us to get mixed up, but the parentheses really don't mean anything, okay? And we're going to add all of that and set it equal to 126 to solve for x. So when I'm adding all of these together, I'm just combining like terms. So I have negative 9x to give us negative 18x, negative 4x for negative 22x, and that's negative 4 more, so negative 26x, okay? Some of you are going to look at this and just know combining like terms. Negative 4 is negative 8, plus negative 9 gives us, again, negative 26x. Okay, so that's when we combine those. Then I'm going to combine my constants together. So I'm going to have negative 4 and negative 4, that's negative 8. Positive 2 would give us negative 6. Positive 2 is negative 4. Again, if you don't set up this equation, you can just look over here and combine negative 4 is negative 8, plus 2 is negative 6, plus 2 is negative 4. So you can combine it all that way. Again, equal to 126 because perimeter is or of 126. So I'm going to add 4. And I have negative 26x is equal to 130. Sorry, let me get a little piece of paper here. Ran out of room. Now to get x, I'm going to divide both sides by negative 26. So 130 divided by negative 26. What number times 26 gives us 130? That's going to be negative 5. Okay, so be careful. We're not going to circle C. Okay, that's not what we're looking for. They're asking us to find the length of the longest side. So now that I have x, I'm able to look at my longest side right here, negative 9x minus 4. Okay, and I'm going to use that and plug in negative 5. So negative 9 times negative 5 minus 4. Negative 9 times negative 5 is 45. 45 minus 4 is 41. So the length of the longest side, B, 41. All right, number 8. Victor paid $110 to get his car repaired. The total cost of repairs was the sum of the amount paid for parts. Okay, so the cost is going to be the sum for the amount paid for parts and the amount paid for labor. Okay, so we're going to be adding those costs together. Victor was charged $60 for parts and $10 per hour for labor. How long did it take to get his car repaired? All right, so when we're looking at this, we want to look at creating an equation. They want to know how long it took, so we're going to have to solve our equation. If you're paying $110 total, we know it's going to equal 110. Okay, remember what he's going to pay is going to be the amount for parts and amount for labor. So it says right here he's paying $60 for parts and then $10 per hour. So that $10 is going to keep reoccurring and be multiplied by X, which will stand for the number of hours. Okay, because per hour, X means number of hours. So I am going to figure out what X is to answer that question. Sorry, we got my computer is getting text messages, sorry. Okay, so 110 minus 60 is going to give us 50. Then dividing by 10, 50 divided by 10 is going to give us 5. So it's going to take 5 hours for his car to be repaired. Number 9, we're going to solve for x. So this is a system of equations. It's kind of small, so I'm going to write pretty small here. Okay, these are both in standard form, where it's x plus y equals the constant, x plus y equals constant. So we're going to use our combination method. To use the combination method, we're going to want the same coefficient, top and bottom, except one positive and one negative. So right here, since I have a positive 6, I can make this one a negative 6 by just multiplying by 2. So I'm going to multiply, oh my goodness, my phone, sorry. I am going to multiply by 2 to this entire equation. So the top is going to be 6x plus 2y is equal to negative 8. Not going to change. And then the second equation is negative 6x plus 2y is equal to 16. Okay, so now that I have the same coefficient in front of x, top and bottom, we're able to cancel out x because we're going to add down, and I'll have 4y is equal to negative 8 plus 16. Different sign, subtract, keep the sign from large number. We get 8. Then we're going to divide by 4, and we have y equals 2. But they want us to solve for x, so we're not done. I actually could have probably eliminated the y solve for x in the beginning, but oh well, I'm not going back in my video, so it's all good. Hopefully you guys are following along. This makes sense to us. We're going to take y equals 2, and we're going to plug it back into one of these original equations. So I'm going to go ahead and just pick, I don't know, the top equation. So here's my top equation, and I'm going to replace y with 2. So 6x plus 4 equals negative 8. Subtract 4, and we have 6x is equal to negative 12. Divide by 6, and negative 12 divided by 6 is going to give me x is equal to negative 2. And that's the answer. Number 10, we're going to look at this following system of equations, and then they're asking us about the graph and what the two lines would look like. So what we should do, well, there's different ways you can do it. You can solve using combination or substitution, but since they're talking about the graphs, what I'm going to do is I'm going to put these both in slope-intercept form. So I'm going to isolate y in each equation. So if this is my first equation, I'm going to put it in slope-intercept form by moving the x term to the other side. So that leaves us with y equals 4x plus 3. Okay, so that's going to be the first line if we were to graph. And then for the second one, this second line right here, 2y minus 8x is equal to negative 2. I want to get y by itself again, so I'm going to move the x term to the other side, the equal sign, and there that is. And then when I divide everything by 2, 8x divided by 2 will give us 4x, and then negative 2 divided by 2, negative 1. So if we compare these two lines, they have the same slope. So they have the same slope and a different y-intercept, which is going to result in parallel lines which do not intersect at all. So the answer is seeing home phone, that meant to say phone sales, in millions per year. We're going to find the slope of the home phone sales. So all we're going to do here is we're going to look at these ordered pairs, and we're going to use the slope formula. So I have 1,600 and 5,200, and here's my slope formula. y2 minus y1 over x sub 2 minus x sub 1. So we're going to use this formula using these ordered pairs, so we can label this x1, y1, x2, y2, and plug those numbers in. So it'll be 200 minus 600 on the top, and then 5 minus 1 on the bottom. And that will give us negative 400 over 4. Negative 400 divided by 4 is negative 100 for our slope. So what we could do is you could have looked at this and like calculated rise over run and saw that it was -4 over, negative 400 over 4, but just be careful with all the different labels on the axes. It might mess you up, so I recommend just writing down the ordered pairs, use the formula. Okay, in a random sample of 1,000 computers of a particular model, 5 have a manufacturing defect. At this rate, how many of 6,000 computers of the same model will have the same manufacturing defect? So this is going to be setting up a proportion. So we can create a fraction out of 1,000 computers, 5 had that manufacturing defect. Okay, and then we can see at this rate how many of 6,000. So out of 6,000, how many are going to have that defect? So you set up like this, the two fractions equal to each other, and then we're going to cross multiply. So 1,000 times x will give us 1,000x, and then 5 times 6,000 is going to be 5 times 6 is 30, and then 30,000. Then we divide by 1,000 to get x by itself, and you can do that trick where you cancel out zeros. 30 divided by 1, we get x equals 30. Okay, number 13, we have this parallelogram, ABCD below, where AC is the diagonal. The measure of angle ABC is 46 degrees, they gave that to us. And the measure of ACD is 61, also written in here for us. We want to find the measure of angle CAD. So CAD is then talking about this angle right here we want to find. So there's different ways that you can look at this. We can see that because these are parallel and these two triangles that are formed right here, these are alternate interior angles. So if this is 61 degrees, then right here is 61 degrees. So what we can also remember is that across opposite of the diagonal here, these are going to be congruent. Okay, I just said that. And then we can look at figuring out the sum of these by our triangle sum theorem. So setting up this equation, because I have a triangle, those interior angles are going to add up to 180. So we have 46 plus 61 will give us 107. Combine like terms and then solve. Okay, so right here is 73 degrees, and again using that alternate interior angles, that will be 73 degrees. Number 14, the ABC Book Club charges a $40 monthly fee plus $2 per book read in that month. The Easy Book Club charges a $35 monthly fee plus $3 per book read in that month. For each club, how many books must be read in 1 month for the total charges from each club to be equal? Okay, so what we're going to do is we're going to look at each equation. We have our ABC Book Club, which is $40 monthly fee plus $2 for each book. So 2x plus 40, because you only have to pay that monthly fee once. And then the 2 depends on how many books read, so that's how we have 2x. Then your Easy Book Club is going to be charging a $35 monthly fee plus $3 per book read. So 3x plus 35. If we want to know how many books must be read, okay, so that's looking for x. For these to be equal, what we're going to do is we're going to set these two equal to each other to find out, to find x. So it'll be 2x plus 40 is equal to 3x plus 35. And we're going to just solve for x. So I'm going to subtract 3x, put it over here. Negative 1x plus 40 is equal to 35. Subtract 40. And divide away the negative 1, x equals 5. So 5 books need to be read in order for the total charges to be equal. Okay, for 15, 16, and 17, we're going to be looking at this parent function, absolute value of x, and then this transformation. So we're going to describe the transformation. Hopefully we remember, we spoke about this in the beginning, this number being multiplied is your a value, and this is going to determine a stretch or shrink. This number is less than 1, so it's going to be a vertical shrink. So the graph of G is a vertical shrink. So we'll put in C, just shrink of the parent function. Okay, so then next we have plus 1 on the inside of our absolute value bars is going to tell us to going left or right. We always change the sign, okay? Think about it as going opposite. So think about this as a negative 1 every time when we're looking at the number inside the bars. So this actually means we're going to be moving left 1 or translating 1 unit left. Okay, so 1 unit to the left of the parent function. And then the minus 5 is going to tell us to move up or down. Since it's negative, it means go down. So we're going to translate 5 units down. So that'll be B. Right, B. The graph of the transformation of f with the correct equation. So what we want to look at is matching each of these transformations with what the graph would look like. Okay, so the negative out in front, we want to remember, is taking your original graph or your original function and it's reflecting it. It's going to flip it upside down or make all of your y values negative. So that is shown right here in number 18. Okay, so number 18 is A. This is showing our x squared flipped upside down, so negative. Okay, for B, this means translate left 3, because remember, when it's inside, you think about it as opposite. So this means translating left 3. So we want to see out of these which one translates left 3. It's going to be 19. So that would be our answer. We match 19 with B. Okay, then x minus 3 squared, again, inside those parentheses, we're going to change the sign and think about plus 3. This means translate right 3. And that's shown right here in number 21. It's taken from our parent function at 0, 0 and going to the right 3. So number 21 will be C. And then last one, x squared plus 3. The plus 3 not inside parentheses will tell us to go and translate up 3, which is shown right here in number 20. Okay. Number 22, let the function f be defined as follows. So here's our function, and we're going to find out what is the value of f of 2. So f of 2 means we're going to have 2 as our input or as our x value. So we're going to be plugging in 2 for our x here and here in the function. So f of 2 is equal to 3 times 2 squared minus 4 times 5 times 2, whoops, sorry, let me get it right out, plus 1. Okay, so again, I'm just plugging in 2 to this x and also to this x. So now we're going to simplify this down. We're going to follow our order of operations. So we have to look inside the parentheses first for our order of operations. So let me leave the rest alone for a second. Inside parentheses, 5 times 2 is 10, plus 1 is 11. So in our parentheses, we're going to get 11. Again, 5 times 2 is 10 plus 1. Okay, Next in order of operations is going to be looking at our exponent. So 2 squared will give us 4. Next, we're going to do our multiplication. 3 times 4 is 12. And then 4 times 11 is 44. And last step, subtract 44 minus 12, and we get negative 32. Okay, we're going to select the ordered pairs that are solutions to the equation represented by the graph. So remember, solutions are all of the points on the graph. These are just the nice points, but there's infinite points, including all the decimal places. But as long as it lies on the line, then it's a solution. So we're looking at -1, -4. That is on my line, so it is a solution. -1, 0 is here, not on the line, so not a solution. 0, -1 is here on my line. That's a solution. 2, 5 is on the line. That's a solution. And then 2, 1 is here. That's not on the line, so we would say 4. We're going to look at the graph of these systems, and for part A, we're going to write the equation of f of x. So f of x is equal to, we know that f of x is a line, so our equation will be in the form of mx plus b. So we need to find b, and we need to find for the slope. So for f of x, -4 is my y-intercept, and my slope, if I pick another good point on the graph like this, I'm going to rise 2 and run 1. Okay, so rise over run, my slope is 2. So the equation of this line would be f of x is equal to 2x minus 4. Again, y-intercept is -4, so that goes here, and then the slope is 2 over 1, so 2 for my slope in front of x. Okay, then my equation for g of x. So now I'm looking at this line right here. So again, we're going to look for the slope and the y-intercept. I have my y-intercept at 5, so I know out here will be plus 5. And then the number in front of x for my slope, I'm going to pick another good point. Right here works. And I'm going down 1, right 1. So my slope is -1 over 1. So -1 over 1, and then we know that we typically, if you leave it like this, that's okay, but we typically don't write the 1 over 1, we just write -x. Okay, so again, the plus 5 was the y-intercept, and then my slope is down 1 over 1, so slope -1. For part C, what value of x is f of x minus g of x equal to 0? So in other words, watch what happens if I add g of x to the other side. We're really just looking at where f of x is equal to g of x, okay? So anytime we're subtracting the functions and it equals 0, it's where are these lines equal, for what value of x. So what we're going to do is we're going to look where the lines intersect. Okay, so where do the lines intersect? And that's going to be right here at x equals 3. So they're equal at x equals 3. Okay. Now for part D, for what value of x is f of x equal to 6? Okay, so there are different ways we can do this. I'm going to show you on the graph, and then I'm going to show you algebraically using the function f of x. So if you were to look this up on the graph, 6 is our output or our y value. So you go to 6 for your y, and then find your f of x graph, which is over here at x equals 5. Okay, so again, you go to 6 on the y-axis, find your f of x graph. It's here at x equals 5. So I know our answer is going to be x equals 5. That's one way to find it, by reading the graph. Otherwise, you can use your f of x function that you created in part A, and 6 again is your output or your y value. So if I were to use part A's equation, it would be 6 equals 2x minus 4, and then I would solve for x. So add 4. 10 is equal to 2x, divide by 2, and we have x equals 5. So 2 ways you can do it. Use the equation or read the graph. Okay, for part E, we can read the graph again. I'll show you how to do that, and then I'll show you how to use the equation. So if I want to find f of 4 in the graph, 4 is in parentheses, 4 is your input or your x value. You go to 4 on your graph for x and find your f. F is up here at 4. So I know f of 4 is 4 minus 2 times whatever g of 1 is. So let's find g of 1. We're going to go to 1 on the x-axis and find our g function, which is here at positive 4 again. Okay, so then when we simplify, we get negative 4. Okay, otherwise, we can use our two functions up here and we'll be able to figure it out. So the second way we could do this is find f of 4. So to find f of 4, you would plug in 4 for x in your f function. So I'm going to do that. F of 4 is equal to 2 times 4 minus 4. Again, I'm using my equation from part A. That's 8 minus 4, which is 4. Okay, so f of 4 equals 4. Then we'll find g of 1. Okay, so I'm going to plug in 1 to my g equation, or my g function up here. So negative 1 plus 5, and g of 1 equals 4. So if I take those numbers and plug them in here, f of 4 will be replaced with 4 minus 2, and then g of 1, sorry about that, guys. G of 1 I know is 4, so I plug that in right here for g of 1. And again, 4 minus 8 gives us negative 4. Okay, so you can either read the graph or use your functions, or do both on your test to double check your work. Okay, number 25. We have the following graph showing the amount of money you receive per hour. So we're going to write the equation of the line and then interpret the slope. So to write the equation of the line, we need to figure out what our y-intercept is and what our slope is. So our y-intercept right here is going to be at 0. So when you're writing the equation of the line, you can use y equals mx plus b, and we already know that b is 0. Now we just need to figure out what our slope is. What is m? So some of us can understand that this point to this point, we're going to rise 8 and run 2. So my slope is 8 over 2, okay? Which is, in other words, y equals 4x, and then we don't have the plus 0, okay? So that would be writing the equation of the line. Again, I knew my y-intercept was 0, so it's plus 0 for my b, and so we don't write anything. And then to find slope, slope means rise over run. Okay, so 8 divided by 2. I am going to show you guys, if you weren't able to see this whole 8 over 2 thing, you do have two ordered pairs. You have 0, 0, and 2, 8. And anytime you have two ordered pairs, you just use the slope formula, and you'll be able to find the slope between them. So our slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then this would be x1, y1, x2, y2, and you just plug in the numbers. So 8 minus 0 for y2 minus y1, and then 2 minus 0 for x2 minus x1. That leaves us with 8 over 2, or 4. So my slope is 4. All right. And then for part B, we're going to interpret the slope in the context of the problem. So we're talking about running, and we have miles traveled and time. So we're interpreting the slope, which means we're talking about this answer, this 4, just the 4 that we got for our slope. So if you look at the context of the word problem, remember slope means rise over run. So it's going to be the change in the y over the change in the x. So if you look at your y, we're talking about miles traveled. and your x is talking about the time in hours. Okay, so when we have 4 for our slope, it means that you're running, why does it say money? I just saw that. Money you receive per hour. Sorry, you guys, that is not what we have. Okay, you run 4 miles each hour. Okay, that's one way you can write it. You can say something like, another way to write this would be the number of miles ran increases 4 miles per hour. That's another good way to do that. So either one of these would be okay, but what you want to understand is that you're running 4 miles each hour, or it's increasing 4 miles each hour or per hour. Okay? All right, number 26, we have 2 high schools in your district are planning a trip to New York City. Your high school rents and fills 3 vans and 4 buses with 112 students. The other high school rents and fills 2 vans and 8 buses with 192 students. There are no open seats in any van or bus, and let's define the variables. So, first of all, let's look and ask what they're actually asking us to find. They want to know how many students in a van and how many students in a bus. So that right there is going to tell you that your X should be the number of students in a van, and then Y would be number of students in a bus. Okay, so based on this, we're going to create an equation to model the situation. So we have our high school and then the other high school. So one equation will be for our high school, one equation will be for the other high school. So the first equation, 3 vans, right? So 3 times the number of students in each van plus 4 buses. So it'll be 4 times the number of students in each bus for a total of 112 students. The second equation comes from the other high school. 2 vans, so 2 times however many students in each van plus 8 times however many students in each bus for a total of 192. All right, so that's going to be our system. Now we want to figure out how many students. So that means we're going to solve this. So really, you could just eliminate whatever variable you want and then just answer the questions. And I think that's what I'm going to do. I'm going to just solve this. And for me, I can see probably eliminating the y could be the easiest. I would just need to multiply the top equation by -2, because if I multiply the top by -2, then I have -8x and -8y and positive 8y, that will cancel. So I spaced this out better on your practice test, but what I'm going to do is I'm going to really small rewrite the top equation. 3 times -2, that'll give us our -6x. 4y times -2 is -8y. And 112 times 2, we can show the work for that here, is going to be -224. Okay, then we can just copy the other equation right underneath because that one we didn't change. Okay, now I'm going to combine. I'm going to add down. -6x and 2x is -4x, and that's equal to 224, and we're going to subtract these. These are different signs, and it's going to stay negative. So we have 4 minus 2 is 2, and then 12 minus 9 is 3. So we have -4x is equal to -32. So if I want to solve for x, I would divide by -4. And I have x is equal to -32 divided by -4. I have x equals 8. Okay, so far I know that there are 8 students in a van. That's what we got right here. 8 students in each van, or in a van. All right, that's the first half of our answer. So that's C. And then part D, how many students can a bus carry? So what we're going to do is we're going to take 8 and we're going to plug it into one of our original equations, and so we will be able to solve for y. I'll use the top equation because those numbers are smaller. And then I'm going to go ahead and replace x right here with 8 and then solve. So 3 times 8 plus 4y is equal to 112. 3 times 8 is 24. Subtract 24. It's going to be 88. And then divide by 4. 88 divided by 4, if you need to show the work for that, you get 22. Okay, so y equals 22 means 22 students fit in a bus. Okay, so we solved our system. We solved for x, we solved for y, and we were sure to label our answers so that we are correctly answering the questions. We don't want to mix up buses and vans. Okay, all right, number 27, we're just solving. So I'm going to remember to first eliminate our parentheses by using distributive property. So the 4 will stay here. I'm going to distribute -2 to the inside. So -2 times -6x is positive 12x. -2 times -6 is positive 12. Copy down the rest. Now combining like terms, 4 and 12 is 16. Now I'm going to move the x to the other side. Move the constant to the other side. 2 minus 16 is -14. Divide by 14, and x is equal to -1. All right, number 28. We're going to graph the linear system and identify the solution, if any. So I'm going to start by graphing this line. At positive 4, that's my y-intercept, and my slope is -3 over 2. Whoops, didn't mean to do that. -3 over 2. So I'm going to go down 3 for my rise, and then run 2, and then put as many points as I can on this graph. Okay, and then we want to use our straight edge to connect those points. Okay, now for my second line, I need to change this from standard form and put it into slope-intercept form. So I'm going to just rewrite this equation here, and I'm going to isolate y. So I'm going to add 4x. I get 2y is equal to 4x minus 20. Then divide everything by 2. And y equals 2x minus 10, right? Because 4 divided by 2 is 2, and then -20 divided by 2, -10. So this is my second line that I'm going to graph. I'm going to start at -10 on my y-axis, and then my slope is 2. So I'm going to rise 2 and run 1. Rise 2, run 1. And I can already see where these lines are going to intersect. So go ahead and draw that line. And when you're solving a linear system or any type of systems, you're looking for where your graphs are intersecting. So our solution is going to be at that point where they intersect. That is at 4, -2. We're going to solve using substitution. So we're looking for an isolated variable. We have y isolated. So we're going to take -4x minus 8 and we're going to plug it in to the other equation right here for y. Okay, so I'm going to copy down that entire second equation, -4x minus 5, but I'm going to throw out the y and substitute in what it's equal to, which is -4x minus 8. Okay, and that's equal to negative 8. So I copy down the second equation, just replacing y with negative 4x minus 8. And now we're going to solve. So I'm going to distribute negative 5. Negative 5 times negative 4x is positive 20x. Negative 5 times negative 8, positive 40. Then I'm going to combine like terms, negative 4x and 20x, 16x. Then subtract 40. Divide by 16, and we have x is equal to negative 3. Okay, so we're not done. Anytime we solve a system, we need to solve for x and also for y. So I'm going to take this answer and plug it into one of my original equations. It's going to be easier to use the first equation, so I'm going to go ahead and do that. So here's my first equation. I know x is equal to negative 3, so I'm going to replace that x right there with negative 3. And then I'll be able to simplify and get y. So negative 4 times negative 3 is positive 12. And then 12 minus 8 is 4. So I have my answer. We always write it as an ordered pair, x, comma, y. So negative 3, comma, 4. For number 30, we're going to compare each function with its parent function and state whether it contains a horizontal translation or vertical translation, okay? So we want to remember that a horizontal translation is when you translate left and right, okay? And then we want to remember vertical would be then when you translate up and down. Neither would be if you're not translating up, down, left, or right. Maybe if there is a vertical stretch or shrink, or if you're reflecting. These are instances of not translations where you might see. Okay, so right here we have a vertical stretch. That doesn't tell us anything for the 3, but this is translating down 1. Okay, so right here, translating down 1 means this is going to be a vertical translation. Okay, for g of x, this is a vertical stretch and that's it, nothing else. So this is just neither, it has neither type of translation. Okay, right here, this means translating 4 to the right. So 4 to the right is a horizontal translation, and then up 5 is going to be vertical. So this is an example of both translations. And then v of x, inside my absolute value symbol means I'm going to translate 2 to the left, so horizontal translation. Okay, number 31 is going to start, or I should say the back side is going to start. 31, we have our 3x3 system. So this one's going to be a lot of steps, a lot of work to show, but we can do this. You guys can do this. Okay, so our first step is going to be to eliminate a variable. So we're trying to create a 2x2 system. So I think by looking at these coefficients, I'm going to eliminate y. Remember, it doesn't matter what you eliminate, but for me, the variable I will eliminate is y. So I have to do this twice. Every single time you're in step 1 when you're eliminating a variable, you have to do it twice to create your 2 equations. Okay, so I'm going to go ahead and use the top and the bottom, the first and the third equations. So because already there's a negative 2 and a positive 2 that will cancel. So I'm going to carefully copy down the first and, carefully, right? And the last equation. Okay, so right here, I'm already able to eliminate y because there's negative 2 and a positive 2. So I'm going to go ahead and do that. I'm going to add down 1 and negative 3x is going to give me negative 2x. Y is cancel. 3 minus 2 is just z, or 1z. 7 minus 10 is negative 3. We're going to go ahead and hold on to this equation for a second. We're going to use that in step 2. Okay, so we want to eliminate y again, but instead of the first and third, I need to choose two new equations. So I can do the second and third, or I can do the first and second. I'm going to go ahead and do the first and second because this one's already negative. So I just need to make this a 2. So I have my first equation, x minus 2y plus 3z is equal to 7. My second equation, 2x plus y plus z is equal to 4. Okay, and we want to eliminate y again. So what I need to do is multiply this bottom equation by 2. So let's go ahead and just rewrite that top equation. We're not going to change it. And then my bottom equation is going to become 4x plus 2y plus 2z is equal to 8, right? Because I multiplied all of those terms by 2. And now when I add down, my y's cancel. 3 plus 2 is 5z, and that's equal to 15. So I just came up with 2 new equations that we want to use in step 2. In step 2, you're going to solve your new 2 by 2 system. So 2 by 2 system means 2 equations, 2 unknowns. So we have 2 equations and we need to find x and z. So my first equation that I came up with, negative 2x plus z is equal to negative 3. The second equation, 5x plus 5z is equal to 15. So we are going to go back to our old lessons where we use combination to be able to solve for x and for z. So I'm going to multiply this top equation by negative 5 because if I have a negative 5 here, positive 5, those will cancel. So my new equation is going to, on the top, become positive 10x minus 5z is equal to 15. Second equation isn't going to change. I'm just going to copy it down. And now I'm going to add down, cancel out my z's. And solving, I get x equals 2. Okay, so now that I have x equals 2, I'm going to plug it back in to one of these 2 original equations and solve for the other variable z. So I'm going to go ahead and use that top equation, negative 2x plus z is equal to negative 3. And I'm going to be plugging in this 2, x equals 2 right here. Okay, so negative 2 times 2 plus z is equal to negative 3, and I'll be able to solve for z. So this is negative 4, then add it to the other side, and I have z is equal to positive 1. Okay, so step 2 is done. Now that I have 2 variables, I'm on to my last step, step 3. I'm going to plug in, whoops, that says plug. My old variables, not my old variables, these 2 that I just found, into the original equation. So we're going to pick any one of these 3 original equations. I'm going to pick the second one just because the numbers are smallest, but either one would work. So I have 2x plus y plus z is equal to 4, and I'm going to be replacing x with 2 because I know x equals 2, and I'm going to be replacing z with 1 because I know z equals 1. So 2 times 2 plus y plus z, which is 1, is equal to 4. This is 4 plus y plus 1 equals 4. Combining like terms, y plus 5 equals 4. I'm running out of room, subtract 5, and y is equal to 4 minus 5, which is negative 1. Okay, so we want to make sure that we write our answer, x, comma y, comma z. Number 32, Kelly and Kim are both babysitters. Kelly charges a flat fee of $10 plus $6 per hour to babysit. Kim charges a flat fee of $18 plus $2 per hour to babysit. How many hours must Kim and Kelly babysit for the total fees to be the same? So I'm going to create an equation for Kim and also for Kelly. Okay, so what we're going to do is we're going to create each equation. Kelly, right here in the second sentence, is flat fee of $10 and then $6 per hour, right? So the $10 is a one-time charge, and $6 per hour means we're going to multiply 6 by the total number of hours. And then Kim's equation, flat fee of $18 plus $2 per hour. Okay, so these are our equations, and if I want to know how many hours, okay, how many hours means we're going to solve for X. Should they babysit for fees to be the same? We want Y to be the same, so we just set these equal to each other. And then we're going to solve for X. And then we'll be able to say how many hours. So I'm going to subtract 2X. Subtract 10, divide by 4, 8 divided by 4 is 2. So Kelly and Kim would have to babysit for 2 hours for fees to be the same. We're going to solve this system by combination. So we want to eliminate one of the variables. So we're looking for the same coefficient top and bottom, one positive, one negative. So right here, I have a 2 and a negative 6. So I can just multiply this top equation by 3 because 2 times 3 gives me positive 6. That'll cancel with the negative 6. So I'm going to rewrite that top equation, multiplying all of the variables by 3, or variables and constants, okay? And then the next equation I'm just going to copy down because it's not going to change. Now when I add down or combine, I'm left with negative y is equal to negative 9. Divide by negative 1, y equals 9. All right, we're not done yet. We always want to solve for x and for y, okay? So I'm going to take y and I'm going to plug it into one of my original equations. I'll pick the top equation, and we're going to plug in y equals 9 right here. So it's 2x plus 9 is equal to negative 3, and then we solve. And x is equal to negative 6, okay? So we want to write our answer always as coordinate, so negative 6, comma 9. And then during your test, if you'd like, you can always plug in negative 6 for x and 9 for y to both equations to check your work. Make sure what you have makes sense. Okay, so for 34, we're going to look at this triangle and we're going to determine if these equations are correct. So what this is looking at is sine, cosine. So we do want to have a little recap on sine and cosine, what they mean. So I'm going to write down this mnemonic device for you guys, SOHCAHTOA. Hopefully you remember it from geometry, where sine of an angle is going to be the ratio of the opposite side over the hypotenuse. Then you have cosine of an angle. It's the ratio of the adjacent side over hypotenuse. And then your tangent is going to be the ratio of the opposite side over adjacent. So that's SOHCAHTOA written out for you, okay? So we're going to look at sine of b and see if it equals to 6 over square root of 11. So here's b. And remember, sine is going to be opposite over hypotenuse. So if this is b, opposite from b would be square root 11. Okay, so if I was finding sine of b, it would be square root of 11 over 6. And they have it backwards, so this is not correct. Okay, cosine of b. Cosine means adjacent over hypotenuse. So from b, adjacent is 5, hypotenuse is 6. So 5 over 6, and that's what we have. Okay, sine of now angle A. So now we're looking at angle A. Sine, again, is opposite over hypotenuse. So from A, Opposite over hypotenuse would be 5 over 6, and that's what they have, so it looks good. And then last one, cosine of A. Again, cosine means adjacent over hypotenuse. So from A, adjacent is square root 11, hypotenuse is 6. So it would be square root of 11 over 6, and that is what we have. So, yes. Okay, last question, number 35. This graph below is going to show the total amount in dollars of a canoe rental modeled as a function of time. Determine whether each statement is true by selecting true or false. So every 30 hours, the canoe rental is $2. So let's see. X is talking about the number of hours, okay? And then your total cost is your Y. So if you want to look at 30 hours that your canoe is rented, it would be like way out here, and the cost would be like way up here, would be really a lot more expensive than $2. So that is false. So they have it backwards. The correct thing would be for every 2 hours, the canoe rental is 30 because of this. 2 being your X is the time, 2 hours, and then 30 being your Y is the cost. So 2 hours, $30. So they had that mixed up. Okay, for every 5 hours, that's 5 right here, the canoe rental is 45. Yes, it's right here on the line. 5 would be $45, so that's true. For 1 hour, the canoe is $5. No, it looks like it's supposed to be up here at about $25, so that's false. The minimum amount a canoe rental will be is $20. So the minimum, so for 0 hours would be here, 20. That's true. That's your y-intercept starting at $20.